Hi guys, let's start a new exercise 1C. But before we start, let's look at the new concepts of this exercise. So this exercise starts talking about surds, which are also known as radicals. What are surds? Surds are nothing but uh, in the form which is written in the form x to the power 1 by n, where x is a positive rational number and nth root of x is irrational. So for example, root 3 is a surd because 3 is a positive rational number and root 3 is irrational. Similarly, third root of 7 because 7 is a positive rational number and third root of 7 is irrational. Now, what does rationalization mean, which is the most important concept of this chapter? Most probably the question in your exam will come from this exercise, which is about rationalizing. Another important concept is what we did in our previous class, which was the representation of irrational numbers on a number line. So let's look at what is rationalization. Rationalization basically means multiplying a surd with another surd to give a rational number. So for example, 3 root 2 is surd 1, which is multiplied with another surd to give us a rational number. So 7 root 2 is the rationalizing factor of 3 root 2 and 3 root 2 is the rationalizing factor of 7 root 2. Now you may realize there could be various multiple rationalizing factor. For example, 7 root 2, if I multiply with root 2, will also give me 7 into 2, which is 14. I could multiply 7 root 2 with, let's say, 2 root 2. It will give me 14 into 2, which is 28. So you could have multiple rationalizing factors, but we usually work with the smallest rationalizing factor, which in this case would be root 2 for this term. Similarly, it will be root 2 for this term. Before we move on, let me quickly realize x plus y multiplied with x minus y is x square minus y square. Why have I written it like this? A plus b into a minus b, or x plus y multiplied with x minus y is x square minus y square. Why am I doing that? Let's look at this term. So root 3 plus root 2. If I have multiplied this with root 3 minus root 2, this would give me first term square, which is 3, minus second term square, which is 2. So that will give me 1, which means I have rationalized these two terms. So we will keep this in mind when I move on to specific question. So it says rationalize the denominator. Basically, it means that I have to multiply it with the rationalizing factor of the denominator. The smallest rationalizing factor would be root 5. So this becomes 3 root 5 upon 5. The objective of rationalizing is to remove the irrational number from the denominator. So now the denominator is a rational number. That's the basic objective, because having an irrational number makes it very difficult to calculate the value. In this case, if I have to rationalize, this is given in the form x plus y. So if I multiply it with x minus y, then I should be able to remove the square root sign from the denominator. So this would be root 5 minus root 2 upon root 5 minus root 2. In case you're wondering why am I multiplying both numerator and denominator, because I can't change the value of the fraction. What I'm multiplying it with is basically 1, and with the same number in the numerator, same number in the denominator. So my numerator becomes 3 times root 5 minus root 2, and the denominator becomes root 5 square minus root 2 square. So this is 3 times root 5 minus root 2, and in the denominator I have 5 minus 2, which means 3 upon 3 root 5 minus root 2, which means the answer is root 5 minus root 2. That's the rationalized form of 3 upon root 5 plus root 2. Let's look at some more questions. So the next question that we do is question number 3, part 7. It says rationalize the denominator of. So again, I multiply this with, this is in the form x plus y. So I multiply it with x minus y, and the denominator also x minus y. This is in the form x minus y whole square, which means this would be x square plus y square minus 2 times x y. So that's my numerator, and the denominator is in the form x plus y multiplied with x minus y, which is nothing but x square minus y square. This gives me 3 plus 2 minus 2 times root 3 into root 2, that's root 6. And in the denominator, I have 3 minus 2, which means the value is 5 minus 2 root 6. Good. Simple one. Next, look at the next one. The next one is question number 3, part 9. Again, this is in the form x minus y, which means I should multiply it with x plus y. So that's the numerator, and in the denominator also I have x plus y. Now the numerator is in the form x plus y whole square, which means this would be 2 root 5 whole square plus y square, which is 3 root 2 whole square plus 2 times x into y, which means 2 times 2 root 5 multiplied with 3 root 2. And in the denominator, I have 2 root 5 whole square minus 3 root 2 whole square. Let's open this. So this is 2 into 2, 4 into 5, 20. And this is 3 into 3, 9 into 2, 18. Plus 2 into 2, 4, 4 into 3, 12. And root 5 into root 2, that's root 10. In the denominator, I have 2 root 5 whole square, that's 4 into 5, 20, minus 3 into 3, 9 into 2, 18. So this gives us 38 plus 12 root 10 upon 2, which means this is 19 plus 6 root 10. Correct. Let's look at the next question. I hope you're getting the hang of it. It's basically the same thing that we've been doing, just in a slightly bigger numbers now. So let's look at the next question. The next question we do is question number 4, part 1. It says find the value of a and b in this question. So let's work with left hand side where I have an irrational number in the denominator. So let's rationalize the denominator. So this is 2 plus root 3 upon 2 minus root 3. If I have to rationalize this in the form x minus y, which means I will multiply it with x plus y. So this is my rationalizing factor. The numerator is in the form of x plus y into x plus y, which means x square plus y square plus 2 into x into y. And in the denominator, I have x square minus y square. This gives me 4 plus 3 plus 4 root 3 upon 4 minus 3, which means 7 plus 4 root 3 upon 1. And since this is given equal to a plus b root 3, therefore we get a is equal to 7 and b is equal to 4. So we rationalize the left hand side and then we compared the value of a and b, and that's how we got the answer. Let's look at the next question. The next question that we do is question number 4, part 3. Again, we need to find the value of a and b. So again, let's start with the left hand side. I have 3 upon root 3 minus root 2. Let's rationalize the denominator. This is in the form x minus y, which means I will have to rationalize it with x plus y so that my square root sign from the denominator goes away. So numerator now becomes 3 times root 3 plus root 2, and in the denominator I have root 3 square minus root 2 square. This is equal to 3 root 3 plus 3 root 2 upon 3 minus 2, which means this is equal to 3 root 3 plus 3 root 2, which is given equal to a root 3 minus b root 2, which means a is equal to 3 and negative b is equal to 3, which means b is equal to negative 3. So that's the value. A is equal to 3 and b is equal to negative 3. Let's look at the next one. The next one that we do is question number 5, part 1. Question 5, part 1 says simplify. So now again, let's see if we have to rationalize both these terms. I'll notice that the denominator of these two separate terms are already rationalizing factors of each other. This is in the form x plus y, this is in the form x minus y, which means instead of rationalizing both of them separately, let me just go ahead and add by taking LCM. So the LCM will be 2 root 3 plus 1 multiplied with 2 root 3 minus 1. That's the LCM. And now in the numerator, I'll have 22 times 2 root 3 minus 1 plus 17 times 2 root 3 plus 1. Let's simplify that. 22 into 2, that's 44 root 3 minus 22 plus 17 into 2, that's 34 root 3 plus 17. And in the denominator, I have x plus y multiplied with x minus y, which is x square minus y square. In the numerator, 44 root 3 and 34 root 3, that gives me 78 root 3 minus 22 plus 17, that's minus 5. In the denominator, I have 4 into 3, that's 12 minus 1. So I have my answer. This is 78 root 3 minus 5 upon 11. That's the simplified form of this expression.